Thank you guys for having me today. My name is Jaden Hamilton. I'm part of the Honors College here at Lone Star College-Kingwood. And as Dr. Nicholson said, yes, I am from California. I see a lot of worried faces, but don't worry, I'm not here to California or Texas. But I am here to talk about earthquakes in San Francisco. So why do we care about San Francisco? I mean, we're Texans, we're in Houston. Why do we care about what's going on there? San Francisco is the 13th largest city in the United States, and it sits on the most active fault in the world, the San Andreas Fault. The San Andreas Fault is a left lateral strike-slip fault, and it categorizes itself as the most dangerous fault because of the damage that it does to the city. Around 5,000 earthquakes hit the San Francisco Bay Area each year, and they could be small, they could be medium, with the occasional larger 7.0 and above, which is the focus of my research today. In order to answer this, I had to ask the question, how has San Francisco adapted to the earthquakes that have told the city since its creation? So doing this, I looked at what scholars said about the early years of San Francisco's history, and then the middle years about when it was younger, and then what they're saying about it today. And I composed a comparative analysis of all of this, and I created a timeline. The infancy period spanning from 1838 to 1905 had 5 total earthquakes throughout this whole time, 2 of which were above a 7.0 magnitude in 1868 and 1865. So as San Francisco was founded by these Spanish conquistadors, it wasn't really until the California gold rush of 1849 that the city really became a boomtown. Lots of settlers from across the United States came in, and immigrants from across the world brought all of their architectural styles with them. An example of this would be the Queen Anne style of houses with wood frames and heavy tile roofs. This meant as the building would resonate heavily or sway, it would be destroyed. Another example of this would be a shingle style house that wasn't tied into the base, and it had solid brick shingles, and this meant that as it was hit by the earthquakes, it was very brittle, and the resonance would cause the building to crumble. Similar to the Queen Anne style, Chinatown buildings were brought from immigrants from China. And these had really weak bases, but also had really heavy stone tile roofs. This meant as the building would resonate or sway, these heavy stone tile roofs would collapse on top of the building. And lastly, these brick warehouse buildings, they were very industrial from the gold rush. They had no base tie-ins, and they were also solid bricks, so that meant that they were very brittle and would crumble during earthquakes. And they were built in San Francisco, but as the city began to fill up, they had no room to put all of these immigrants and settlers. So what did they do? They dug up mud and sand from the bay and filled the outside areas. Here you can see in blue and purple, demonstrates 30% of the city is built on oceanic sedimentary fill. All of the buildings that were built onto this were set to be destroyed from ground subsidence and liquefaction. The rest of the city, of course, is sedimentary rocks and bedrocks. But the ground subsidence and liquefaction happened because as the sedimentary fill of mud and sand was brought into the city, it would cause sinkholes, and these grains of sand and mud would then turn almost to liquid as they tried to find a level ground during the earthquakes. This meant that all of the buildings on top of it would be destroyed. The gas mains and electrical conduit underneath would be destroyed as well. So the buildings that were destroyed once looked like this, and after the earthquakes then looked like this. In black, you can see longitudinal and latitudinal bracing to provide extra rigidity in these buildings when hit with resonance from the seismic waves. On top of this, in orange, we can see unit bases, which provide extra bases for the building to move with the earthquake. In the middle period, there were about 6 earthquakes, magnitudes 4 to 5, but 1 earthquake above 7.0 magnitude, and that was the Great San Francisco Earthquake of 1906. This had a magnitude of 7.9 to 8.2. This was the most devastating earthquake in the city's history. Not because of the earthquake specifically, but because of the fires. As the ground would subside, it would break the electrical lines and gas lines underneath the ground. And this is what caused the fires to start. We can see that in Site A, where the ground is sinking, and that's exactly where it happened. In Site B, we can see structural damage, as well as in Site C, we can see these longitudinal and latitudinal braces left standing from when the building burned down from the fire. But it wasn't until a year after the Great San Francisco Earthquake where building codes adapted. The idea of fire blocking was implemented in the city, and all of these electrical lines and gas conduits were ran through extra thick conduits and concrete duct banks underneath the ground to provide extra structural support. This meant if the ground were to subside again, they wouldn't snap as easily and definitely wouldn't cause the fire that destroyed 80% of the city last time. On top of this, bracing standards of 20 pounds per square foot were brought in. This meant that as buildings used to look like this, then looked like this, we could see thicker longitudinal and latitudinal bracing, but also diagonal shear bracing to provide extra rigidity to these buildings, and the stiffness of the buildings was just much more up to code. In the modern era, spanning from 1985 to the current, there have been 4 earthquakes, one of which is above a 7.0 magnitude, and that's the Loma Prieta earthquake of 1989. The focus of the modern era was really to bring modernism into these buildings. This meant extra physics on kinetic energy dispersion systems. Shown in these photos above, you'll see buildings with suspension systems built into their braces. This meant as the upward acceleration of resonance traveled through these buildings, it almost slowed down the effect of resonance through the building. Much like when you're in your car and you go over a speed bump, you don't hit it super hard, but the suspension systems in your car slow the impact. And that's exactly what these buildings did. Another example of a kinetic energy dispersion system implemented in the modern era are in these 4 buildings. In sites 1 and 3, we can see the implementation of a mass-tuned damper. This is essentially a giant ball hanging from the top of the building set to move opposite of the way that the building sways. So if the building were to move this way, the ball would move opposite to disperse the kinetic energy and reduce the impact of the sway. In sites 2 and 4, the same thing happens, but instead of having a mass-tuned damper, they actually had large pools of water. The water acts as the same thing, but moving the opposite way of the building, and this disperses the kinetic energy in a different sense. From all of this, I've created 2 graphs, a damage per period graph and a deaths per period graph. In the damage per period graph, we could see a downward slope in all of the damage throughout the city's history. In the infancy period, we could see $21.7 billion in damage, the middle period, $14.7 billion in damage, and the modern era, just $6 billion in damage. All of this is adjusted to be inflation to be brought to today's money. So obviously it wasn't $21.7 billion at the time, it was about $400,000 at the time. But in today's money, that is essentially $21.7 billion. In the deaths per period graph, we can also see an insanely downward slope on the graph, going from 3,600 down to only 63. Because of the records kept at the time of the infancy period, not much was known about how many people had died, so I had to go through population density of the city at the time to estimate the fact that there was about 3,600 deaths. All of this being said, the city's history has really gone through a lot. Many earthquakes, much damage, much death, but throughout the time of the infancy period, the middle period, and the modern era, we've seen death, damage, and destruction on a steady decline. And hopefully throughout the next years, we will see no damage, no death, and no destruction. Future research could be done on the modern era, as it's still happening today, and we don't have enough earthquakes to provide data on this. Thank you.